Hello friends, this is Amar Hatti, your CAD/CAM teacher. Well, in the last video lecture, we started your advanced manufacturing method. That is your 5th unit of your CAD/CAM. Okay. So in last video lecture, we came to know what are the different categories of the manufacturing process. Those are subtractive manufacturing process, additive manufacturing, and formative manufacturing process. And also we had the introduction to rapid prototyping techniques, and also we seen what are the basic steps in rapid prototyping method. Okay, and along with that we came to know what are the advantages, disadvantages of the rapid prototyping method, and we also had the classification of rapid prototyping systems. Okay, well we have three types of rapid prototyping systems. One is liquid based rapid prototyping, second one solid based rapid prototyping, and the third one is powder based rapid prototyping system or technique or method, whatever you can call. Okay, so the first one is your liquid based rapid prototyping system. So what is liquid based rapid prototyping system? In this one, simply the initial material used is in the form of liquid state. Okay, liquid used is organic resin actually that cures and solidifies under the exposure to light. Okay, well in this one we have two processes. One is stereolithography and polyjet modeling. Okay, so but as per your syllabus you have only stereolithography. So let's see what exactly the stereolithography has. So it comes under your liquid rapid prototyping method. So it is actually the most widely used rapid prototyping technology, and it is the liquid based rapid prototyping system. So in this one it is this stereolithography, or we can call it as SLA process also, which will be based on two principles actually. Where the first one is parts are built from curable liquid resin. Curable liquid resin. Okay, liquid resin, we are using the initial material in the form of liquid, that's why we are using liquid resin. And the layer of this curable liquid resin, that is actually the thermosetting plastic is actually going to expose to a laser beam, due to which it is going to cure and solidify itself. Okay, so this is the first principle, you can use this one. And the second one is part is directly built layer by layer by repeating the process. Just the part is built layer by layer just by repeating the process. Okay, so these are the operational principles. Well, what are the different components of the stereolithography process? Well, you can see it in the picture. We have a pre-processing computer, we have a stereolithography system computer, then a control unit to control all the mechanisms, then optical scanning system, helium, cadmium or argon iron layer we use to cure and solidify the layers, then a vat which is actually filled with liquid resin. We have downside, we have a vat filled with liquid resin, then a build platform where we are going to build the part, then sweeping wiper blade which is going to wipe out the extra thing what is not needed. So what are the working processes, how it is going to working of stereolithography process? In the first step, whatever we are manufacturing, first in initial step we must have a 3D CAD model. So first step in this process is the creation of 3D model. What is the next step? Well, this is a rapid prototyping technique. So we have to generate a stereolithography file, that is STL file. We have to generate STL file. Then the part orientation, if it is needed the support, then we have to support generation we need to do. Then we need to check for STL files. If we have any defects, if we have any curable form of some defects, then we have to check it. Then transmission of STL files will be done in a format where the machine is going to read. Then the slicing of STL model will be done. So what is the third step? Well, in the third step, the real part building process starts with the transfer of this sliced file format data to rapid prototyping machine by system computer. Well, these three steps will remain same for all the rapid prototyping techniques. Okay. So next comes, so this stereolithography system consists of an elevator build platform which is mounted in a vat of liquid resin. You can see it here, we have a liquid resin, and it is also consists of an elevator build platform. Okay. So the computer controlled optical scanning system is going to redirect the laser beam onto it. So this laser beam is actually a computer controlled optical scanning system. The laser beam is going to scan and solidifies the first layer of liquid resin corresponds to the sliced data of 2D cross section to a depth greater than 1 layer thickness. So I said we are going to manufacture the part layer by layer, and we are going to cure and solidify by using the laser beam. So once after scanning and solidifying one layer, the build platform is then lowered by a depth actually equal to 1 layer thickness and left for short time, so that this liquid resin settles on the cured solid layer. So once this solid liquid resin settles on the cured solid layer, a sweeping wiper blade moves across the surface to coat a new layer of resin on the solid layer, and the thickness of new layer of resin is equal to 1 layer thickness. Well, this thickness of 1 layer will be predefined as per your changing processes. The laser beam scans and solidifies the new layer of liquid resin. So the process is repeated until your part is completely built. Okay. Then the build platform is then raised out of the vat and part is removed for post processing. In post processing, what we do? A part of post processing part is placed in an ultraviolet oven to harden any uncured resin. If we have any uncured resin, we are going to keep the part in ultraviolet oven and it is going to harden itself. Okay, so this is the working principle of stereolithography process. So what are the advantages? Well, if you see the advantages by stereolithography, we have a good dimensional accuracy we are going to obtain, and also the surface finish we are going to obtain. Well, if it has any advantages, then definitely it has disadvantages. Mainly the main disadvantage of rapid prototyping, if we tell you, that is the high initial cost. And also this stereolithography process requires the post processing, the curing, then hardening and all, and also it requires the post curing. Okay, so these are the limitations. So where we use this one, the applications? Well, any concept models if I want to do, we can use that one, and also if I am going for the prototype design, analysis and functioning testings, I am going to design the products by using stereolithography. Okay, so that is about the first one, that is liquid type of rapid prototyping method. Well, you have only one as per your syllabus, and the second part is your solid based rapid prototyping technique. In solid based rapid prototyping system, we have two types. One is fused deposit modeling and the second one is laminated object manufacturing. So in solid based rapid prototyping system, same, the initial form of the material used is in the form of solid. Okay, so this solid state, we use it in the solid state, right? So what are the different types of solid state it is going to include? Well, it is going to include the material in the form of wires, in the form of rolls, in the form of laminates or pallets. However, it does not include powder form, only in the form of solid. Okay, well, the first one is your fused deposit modeling, and it is the second most widely used rapid prototyping technology after stereolithography. Okay, so in this process, material used is actually thermoplastic. Thermoplastic in the sense, you can tell the examples like polycarbonate, polysulfone, etc. So and it is in the form of wire-like filaments. We use wire-like filaments to manufacture the material by using fused deposit modeling. So what are the parts or the components we use here? We use pre-processing computer. Every rapid prototyping process needs the pre-processing computer. Then fused deposit modeling system computer we need. Then the control unit. Well, these three will be used in all the things. Well, we add just the extra things like FDM head with dual tip nozzle we use. Platform heating system we use, and also a build platform to build the material, build the object. Okay. So what is the working principle of fused deposit modeling? Well, I said the first, second and third steps remain same. The first one is the creation of 3D model. Well, the second one is STL file generation, then part orientation. If we need to generate the supports, then checking of STL files for any defects, transmission of STL files, then slicing of STL files. Then the real part building process starts. Okay, so, well, these three processes will remain same. Well, in the fourth step, in this part building process, the thermoplastic material, that is polycarbonate or polysulfone, in a filament form. I already said we use it in the form of filaments. So in filament form is going to heat slightly above its melting temperature in a fused deposit modeling head using the heating system. What we do? We use the material in the form of filaments, and we are going to heat it in a FDM head slight above the melting temperature of the material. Then the semi-liquid material is going to extrude through the movable nozzle that travels in X and Y plane to create a two-dimensional layer of material on the build platform. So this process is like, in a simple sense, you have seen the baker, right? You have seen the baker, and that baker is decorating a cake. Okay. A controlled extrusion helps to deposit a thin layer of the material, and the build platform is maintained at actually a lower temperature so that the thermoplastic quickly hardens. Okay, so that thermoplastic is actually quite higher temperature than its melting point. Then the build platform which we are using is maintained quite lower temperature so that this thermoplastic quickly hardens. So the material solidifies within a very short period of time once after extrusion, and the cold welds to the earlier layer. So the movable nozzle is of dual tip actually. Okay, so that movable nozzle is of dual tip. One nozzle tip for producing the part geometry, and another nozzle tip for producing the support structure. One for producing part geometry and another nozzle tip for producing the support structure. You understood that one? So once a layer is built, the platform lowers, and extrusion nozzle deposits another layer of the material. Simple. And the material solidifies within a very short time after extrusion, and it is going to cold welds to the earlier layer, and this process is repeated until the part is completely built. So the part is once built, then removed for post processing. Well, the support structure can be removed manually or dissolved by putting into solution. Okay, so that is the simple process. So what are the advantages of fused deposit modeling? Well, if you've seen, it is easy to remove the structures or supports what we are provided, and also it has a temperature stability process, and the parts what we produce are going to have or possess high strength. Okay, and it is safe operation. We don't need any we don't have any risk factor in this one, so it is a safe operation. So what are the disadvantages? Mainly, this is a rapid prototyping, so high initial cost, and if you've seen the accuracies, it has a limited accuracy of parts, and also it takes quite a higher time to build the object, so it is a slow building process. So these are the disadvantages of fused deposit modeling. So what are the applications of the fused deposit modeling? Well, in medical applications, medical field, we can use that one, and definitely for prototyping, design, analysis and functional testing we use this one. Okay, so this is about fused deposit modeling. So next one is your laminated object manufacturing. Okay, so it is a solid based rapid prototyping system. So the difference, or in this process, a thin sheet or laminate are coated with adhesives on one side is used as a material, where in fused deposit modeling we used the material in the form of filaments. Okay, so in this process we use a thin sheet or laminates actually coated with adhesives on one side, and it is going to used as a material. Well, what are the laminates we use? We use plastics, we use some metals, or we use ceramics also. Okay, so what are the components we use in laminated object manufacturing? Well, the same. We use pre-processing computer, laminated object manufacturing system computer, we use control unit, then optical scanning system we use, then carbon dioxide laser we use, then supply roll, take-up roll, the material what I am talking about, the supply roll and take-up roll, a heated press roller we use, and a build platform we use. Those are actually the components of this system. So how or what are the working principle of laminated object manufacturing? Well, the first step remains the creation of 3D model in any graphical package. Then STL files we need to generate, part orientation we have to take care, we have to check the STL files for defects, transmission of STL files to the format where the machine understands. Then the slicing of STL model we have to do. Then after this one, a real part building process starts once we transfer the slice file format data to rapid prototyping machine by using system computer. So this laminated object manufacturing process typically consists of 3 steps. Well, the first one is placing the material, that is thin sheets or laminates, then bonding the sheet or laminate to previous layers. Once I keep a layer, then I am going to keep another layer. So bonding of this sheet to the previous layer, that is the second process. Well, the third one is cutting the laminate as per slice layer data. Cutting the laminate as per slice layer data. So what is the next step? Next is the material consists of continuous and long thin sheet or laminates, which is actually made of plastic, metal or ceramic, which is coated with heat activated adhesive from lower size. From lower side it is coated with a heat activated adhesive. What is heat activated adhesive? Well, the properties of the adhesive or the adhesion will be activated once the heat is activated. Okay, so the material is rolled up on supply roll, it passes over the build platform and finally goes to the take up roll. You can see on the right side we have a supply roll, in between we have a build platform, then to the left we have take up roll. So the heating press roller passes across the sheet after placing it on the build platform. Due to this heat activated adhesive, the layer is bonded to previous layer. Then we have a carbon dioxide layer beam which is going to cut the cross sectional outline of the layer as per the slice data of 2-dimensional cross section to a depth of exactly 1 layer thickness. It is not going to cut the below layers. Okay, it is going to cut only with a depth of exactly 1 layer thickness, and the optical scanning system controls the XY motion of the laser beam. So after cutting of one layer is complete, the build platform is going to lower itself with a same depth equal to one layer thickness. The remaining portion of sheet in wound on a take up roll, and sheet for next layer is supplied by the supply roll. The process is repeated until the part is completely built. Okay. So the last step is post processing, which includes separating the part from its support material and cleaning, finishing it. Okay. So this is the working principle of laminated object manufacturing. So what are the advantages? Well, if you see, the low material cost will be one of the advantage of laminated object manufacturing, and of course it is a faster process and high accurate process, no doubt in that, and also no post curing is required in this one. Only the cleaning and finishing is much more than enough. So what are the disadvantages? Well, one of the disadvantages is it has a limited strength of parts. It doesn't have the high, it is not going to possess the high strength of the parts, and it has actually a tedious process of removal of the supports. If you want to remove the supports, it is actually a troublesome. And if I want to build the hollow and thin walled parts, it is quite unable. That is one of the disadvantage which is going to falls into laminated object manufacturing spec. Okay. So the part manufactured by using LOM, where we use it. Okay. Same for prototype making and functional models in low stress environment. If I want to go for that, we use that application, and mainly the products for medical application we use. Medical application process in the sense it is used for making the models of human organs, like if we have bones, we have skull, etc., like that. So for making the same prototype, we use laminated object manufacturing. Okay. So this is your laminated object manufacturing. Next comes, well, you can see here the same laminated object manufacturing. We have a new layer, and we have a layer which is going to place it on the build platform. Then a heated roller is going to roll onto it, so that the adhesives will be activated and get attached to the previous layer, and optical scanning system is going to cut the sheets as per we require. Okay. So next comes is your powder based rapid prototyping systems. Well, in the powder based rapid prototyping system, the initial form of material used is in the powder state, like grain like forms we have. Okay. So in this one we have two types of the methods or systems. The first one is selective laser sintering, and the second one is 3D printing. So let's see the selective laser sintering. So this process is more similar to stereolithography process, but the only difference is in selective laser sintering process, the material used is powdered polymer or powdered metal composite instead of liquid resin. In stereolithography we used liquid resin, but here we use powdered polymer or powdered metal. So hence in selective laser sintering process, the powdered polymer or metal composite layer is sintered by selective scanning of surface of powder bed using the laser beam. Using the laser beam, we are going to sinter the selective scanning surface of powder bed. So what is the principle of operation? So this process is based on principle that powder of thermoplastic material, metals, composites or ceramics is sintered layer by layer under the heat produced by carbon dioxide layer to build the part. Okay. So what are the components used in selective laser sintering system? Well, we use pre-processing computer, selective laser sintering system computer, control unit, optical scanning system to cut, and carbon dioxide laser. Well, we need powder feed bed, part build powder bed, power bed, powder feed platform and cylinder, part build platform and cylinder, roller mechanism and process chamber we need. So these are the components used in selective laser system. So what is the working principle? What is the working principle? Initially we must create the 3D model, then STL file generation, part orientation, checking of STL files, transmission of STL files, slicing of STL model, then the real part building process starts. If I am going to transfer this slice STL file format data to rapid prototyping machine. Okay. So this selective laser sintering system consists of powder feed bed containing powdered polymer. Well, you can see here we have a powder feed bed which contains powdered polymer. Well, that powdered polymer may be nylon, that may be polyamide or any other polymer, okay, or metals, composites or ceramics, whatever the material it can consist, but only in this form of powder. So the powdered polymer used in this process are thermoplastic materials, and the computer controlled optical scanning system is going to redirect the laser beam onto the powder, and the laser beam scans a layer of powder corresponding to slice data of 2D cross section to a depth quite greater than one layer thickness, and it is going to carries out the sintering of the powder layer. Okay, so the heat generated by this carbon dioxide laser increases the temperature of powder to a melting point, fusing the powder particles to form a solid layer. It is going to fuse the powder particle to a form of solid layer. The intensity of this laser beam is controlled such that it is going to melt and fuses the powder only in the area defined by the slicing data. It is not going to melt and fuses the powder for the area other than defined by the slicing data. Okay. Next, what happens after scanning and sintering one layer? The part build platform is going to lower by a depth equal to one layer thickness, same as stereolithography, only the material is different. So a roller mechanism is going to convey a new layer of material from powder feed bed on top of the previously sintered layer for the next scanning and sintering process. The process is repeated, and this process is going to repeated until the part is completely built. As sintering operation is performed by high power carbon dioxide laser, the build platform and the powder bed has to be preheated to certain temperature to avoid part deformation. Okay. So once all this process is over, the part is removed from this process chamber and the loose powder just falls away, and the part or prototype is finished by post processing operation like sanding or painting. Okay. And if you've seen the advantages of the selective laser sintering, we don't need any support for this one, and high rate of production it has, and minimum post processing will be required. Those are the advantages of selective laser sintering. So what are the disadvantages or limitations? Well, it needs a high running cost, or initial cost for this one will be higher, and selective laser sintering has poor surface finish. Why? Because the material used is in the form of powder. So we are going to have the low surface finish. So what are the applications? Well, same for making the prototypes, and if you want to make any tools or machine tools, we use those tools, or we manufacture those tools by using selective laser sintering process. So this is the schematic diagram of selective laser sintering system. Everything will be same, but only the schematic diagram of this selective laser sintering. So the second one, in this one, the powdered rapid prototyping system is 3D printing. Okay, so 3D printing is actually widely used process nowadays. What we are talking, so in this 3D printing process, in order to create 3D prototype, the layer of deposited powder are solidified by the layer of this deposited powder are solidified by injecting liquid adhesive binder using multijet printer head. Well, you have seen here in selective laser sintering process, it is quite similar to that. The difference is in 3D printing process, the liquid adhesive binder is used to bind the powder material instead of using a laser to sinter the powder material. We just used adhesive binder. Okay, we used adhesive binder. So what are the components of 3D printing system? We must use pre-processing computer, we must have 3D printing system computer, a control unit. Along with that, we need inkjet print head, liquid adhesive supply system we need, then we need powder feed bed, part build bed, powder feed platform and cylinder, and part build platform and cylinder. Well, you can see that in a diagram of 3D printing. So what are the working step of 3D printing system? Working of 3D printing system. Same, in the first step we are going to create the 3D model. In next step we need to generate the STL file, take care of part orientation, check the STL files, transmission of STL files, then slicing of the STL model. Okay. Well, in the third part, the real part building process starts once we transfer this sliced STL file format data to rapid prototyping machine by computer. So the 3D printing system consists of powder feed bed containing a full of powder. Okay, so the powder material commonly used in this process are starch powder, plaster powder, ceramic powder. Okay. A multi-jet print head is going to deposit a liquid adhesive to the targeted regions of the part build bed corresponding to slice data of 2D cross section to a depth which is equal to 1 layer thickness. These regions of powder are bounded together by the adhesive at the locations where it is printed. As per the information we received from the 2D cross-sectional section. So the remaining free powder supports the part during build process. After forming one layer, the part build platform is lowered by a depth equal to 1 layer thickness. Same in all the rapid prototyping system. Once one layer is deposited, the part build platform is lowered by a depth equal to 1 layer thickness. And we have a roller mechanism which is going to spread a new layer of material from powder feed bed on top of the previously printed layer for printing of next layer. So the process is repeated until the part is completely built. Okay. So after completion of printing process, the part is removed from the build platform and loose powder will be falls away just. So what are the advantages of using 3D printing? Well, in 3D printing, we can use wide range of materials for different parts, and with high speed we can manufacture the parts, and it is very simple to operate, and minimum wastage of material will be occurred in the process, and we don't need any additional part supports for manufacturing the parts by using 3D printing. So those are the advantages. So what are the disadvantages? If you've seen especially about 3D printing, we are going to have the poor strength of the parts. We are going to obtain the strength of the parts very poor. Okay. So the material we used is in the form of powder. So the poor surface finish we are going to obtain. We are going to have the poor surface finish. Those are the disadvantages of 3D printing. So where we are going to find the application of 3D printing process? Well, in concept models we are going to find it. If I want to make the molds, then I can make the mold by using 3D printing. And if I want to go for the functional models, and what is functional models? Used for making the parts from composite material for functional testings. Like for example, silicon carbide is infiltrated with molten material to make a composite material part. So there I can use my 3D printing process. So these are the different types of your rapid prototyping systems. So please read well the 5 rapid prototyping systems. Okay. So in the next class we are going to start your rapid tooling process. Rapid tooling process, what are the classification of rapid tooling, then what are the different STL file formats, advantages of STL file formats. Then we also have the 4D rapid prototyping system. As we have 3D printing, we have 4D printing also. Till that your first part of 5th unit will complete. Then we can move to the product life cycle management. Product life cycle management we can move in the next class also. So till that, do watch all our videos to get understand well about your syllabus. Okay, till that, have a happy day. Bye guys.